Hi guys, so today we're going to talk about limits and why you need to learn them.
I don't know about you, but limits were one of the first things that I learned in my calculus class, and I always wondered kind of what they were and why they were there. So, generally, when you first start out learning about limits, you're taught them in terms of what a function approaches. So, let's say you have let's just say, a function that looks like this, and maybe they'll ask you what value does this function approach as x approaches 2. So what value does it approach as you go this way, and what value do you approach as you go this way? So let's just say if it was the limit as x approaches 2 of x squared, and that would actually equal 4. Oops, 4. There we go. I only drew half of this function, by the way. The other half would go this way, but that's not really important. Okay, so anyways, back to why we learn limits. So in order to understand that, we kind of need to understand calculus as a whole. So calculus is actually broken up into two major parts. There is the differential aspect, and then there is integral calculus. And right now we're going to focus on differential more, just because this is what you learn first. So when you first learn differential calculus, you have to learn how to find the derivative. There we go, derivatives. Okay, so that will be introduced to you as this equation. So f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x over h. So don't worry about what this equation means too much at this point, but the important thing I want you to notice is this is why you have to learn the limits. This is where your whole, introduction of limits is going. Because with derivatives, basically what you're going to end up doing is, let's say you have a function that looks like this, something like that. You can have a secant line that goes through here. So the secant line will cross this function at 2 points, which is here and here. And eventually you're going to minimize the distance between the 2 points it crosses. So eventually, here, let's say you take one more, that still crosses here and here. And then eventually you're going to end up with the tangent line, which looks like that. And the tangent line is actually going to give you the slope at a point. So the secant line always goes through 2 points. The tangent line is just going to go through this 1 point, or at least be infinitely close to that point. That's why you have to take the limit. So that is basically why you learn the limit. Derivatives basically have a lot of applications, one of which I'll just give you one example. One would be to maximize profit. So let's say you have 300 apartments to rent out, and your profit is given by this equation. X squared, let's just say plus 2500 x minus 100. This is actually a parabolic function. So if you want to maximize your profit, you can actually take the derivative of this function, and then that will give you the number of apartments you should always have rented out in order to maximize your profit. Just one more, you can also, maximize area. So let's say you want to have a garden and you want to have, the maximum area that's possible, but you only have a certain amount of fencing. So you can actually take the derivative to find the dimensions of the length and the width that will give you the maximum area. So hope that helps. If you have any questions, leave me a comment. I also offer tutoring. I'll put my email in the description. And yeah, let me know if you have any questions. Thanks for watching.